Okay, let's solve this problem together. There might be many ways to solve this problem. So if your answer is correct, then don't worry, even though your answer is different from what I have. First of all, we want to change the values of the diagonal elements. That is our first job. How can you access to the diagonal elements? You can use NP arrange 4 and NP arrange 4. Then it's going to be combination of 0, 0, 1, 1, 2, 2, and 3, 3. And then I'm going to push range 4 because this is going to be 0, 1, 2, 3. So that is our first thing to do. And as I told you, there are many ways to solve this problem. So don't worry if your answer is different from mine. And I'm going to add 1 to the values that are greater than 0.5, 0.8. How can I get those numbers or positions? Using this Boolean mask. So x greater than 0.8. And I'm going to add 1. Okay, and the next topic is linear algebra with NumPy. In the lecture slides, I told you that linear algebra is closely related to machine learning and deep learning because we can express networks using matrices, and we can also represent models, data using matrices. Therefore, linear algebra plays an important role in machine learning and deep learning. And NumPy is a very powerful library supporting linear algebra operations. And we can define row vector like this, and column vector like this. So I'm going to print row vector and column vector. So they look different, row vector and column vector. And when you try to change the dimension of row vector, rather than using reshape, you can do something like this. np.new axis. The new axis is created and it becomes a column vector. Another thing is you can just add none here. Then another axis is created. So you can use np.new axis or not. Both are fine. They actually do the same thing. Let's define a matrix that looks like this. After that, we can do matrix multiplication using np-mat-mul, matrix and column vector. And it will become 14 and 32. Why is it so? Because we are matrix multiplying 1 to 3 and 1 to 3, that goes 14, 5, 4, 5, 6, 1 to 3, that becomes 32. However, sometimes you need to be very careful about np-mat-mul, because in theory, this matrix cannot be multiplied by row vector. However, when you do this, matrix, it will not occur an error. or rather, these values are returned. Similarly, you can even do NP metmul, row vector, and row vector. You cannot perform this operation because they are the same vector dimension. You need to transpose one of them to perform matrix multiplication. However, NumPy allows this using broadcasting. So when you see some things are not very what you expected, then you need to you can inspect this part. And calling np-metmul all the times could be cumbersome. In that case, you can use this symbol, @ and perform matrix multiplication like this. And I mentioned that you can do transpose, calling transpose like this. However, writing transpose can be tedious, so you can use capital T to transpose a matrix. So you can perform many linear algebra operations using NumPy, but sometimes you might want to do more advanced things that NumPy doesn't support. In that case, you can use SciPy library. This library is built on top of NumPy, and they are very flexible. So you can use SciPy with NumPy. So when you're looking for some functionality and NumPy does not support that, then you can have a look at SciPy. All right. And the last topic we're going to talk about today is matplotlib. This one is to draw some nice plots using Python. You can import this module using import matplotlib.pyplot as PLT. And you can draw functions using PLT plot like this. However, you need to explicitly call this plt.show method to draw this figure. If you remove this part, it will not draw a figure. It should not draw the figure, however, it is drawing this figure. Anyway, technically, it should not draw this figure if you don't call this part. And another thing is, you can add, the reason why we need to call this expression explicitly is because on the way, we want to do something different. Like we want to do some more things like adding the limit of the x-axis or y-axis. Like this. And we might want to add label to x-axis or y-axis. So after we configure this figure then show, then the limit of the x-axis and y-axis have changed, and these labels are added. Okay, and there are many other things you can do with PLT. Let's say this was a graph. However, we can do something called scatter plot. So as the name suggests, you are just scattering some points like this. So this is not just a graph, but it is plot of some points. And you can do various things with plot. Another example is bar plots. So after defining some necessary variables for bar plots, you can call PLT bar. Then it will show you a bar graph like this. And you can also draw histograms. I'll just show you the code like this. And you can even overlap two histograms like this. Don't worry about this code. These codes are very simple and straightforward like this. And you can also draw some plots in one figure, multiple plots in one figure like this. So long story short, PyPlot offers very versatile functions to draw many types of figures. And you can use Matplotlib for your research as well.